Artificial intelligence is often described as intelligent, autonomous, and reliable, but the real world has a way of exposing its limits. When an artificial intelligence system fails, it is tempting to blame a software bug, a faulty sensor, or poor engineering decisions. But in most real deployments, failures are not accidents. They are consequences of systems trained and controlled, simplified environments, and deployed into a world that is dynamic, noisy, uncertain, and constantly changing. An artificial intelligence system does not fail because it is careless. It fails because the real world is more complex than its training data. What you are seeing here is not just a failed robot. It is a visual representation of the fundamental limits of artificial intelligence and robotic systems. Modern AI systems are designed to optimize specific objectives. They process large volumes of data, detect statistical patterns, and generate outputs based on learned models. These systems do not understand goals or intentions. They optimize numerical functions. Robots extend these models into the physical world. Together, artificial intelligence and robotics form closed-loop systems that rely on perception, decision-making, and control. Sensors observe the environment. Algorithms interpret the data. Control systems execute actions. When all components operate within expected conditions, these systems appear intelligent, precise, and reliable. But when conditions change, limitations become visible. Artificial intelligence does not understand context. It does not reason about cause and effect. It does not recognize when its assumptions no longer hold. It predicts. Robotic systems rely on sensors such as cameras, lidars, inertial measurement units, and force sensors to perceive reality. These sensors convert the physical world into numerical signals. AI models process these signals and output actions. If sensor data is incomplete, delayed, biased, or noisy, the system does not question it. It acts on it. This is where failure begins. Small errors in perception can propagate through decision layers and control algorithms. What begins as uncertainty in sensor data can grow into instability in motion, planning, or interaction. This phenomenon is known as error propagation. AI models are trained on historical data distributions. When they are deployed in environments that differ from those training conditions, performance can degrade sharply. This is known as distribution shift. Unlike humans, AI systems cannot generalize through reasoning or experience. They do not adapt unless they are explicitly retrained, recalibrated, or redesigned. Robots do not improvise. They execute predefined policies. When unexpected situations occur, AI-driven systems either revert to fallback behaviors or fail safely. The image you are seeing represents this moment. Not a malfunction, but a boundary. The boundary between optimized performance and real-world complexity. Artificial intelligence systems do not understand failure. They do not reflect on mistakes. They do not learn in real time unless explicitly designed to do so. This is why human oversight remains essential. Artificial intelligence and robotics are powerful tools. They can automate processes, optimize decisions, and scale analysis far beyond human capability. But they are not autonomous intelligence. They require careful system design, continuous monitoring, validation, and human judgment. Understanding how and why AI systems fail is not a weakness. It is the foundation of responsible deployment. The future of artificial intelligence will not be defined by how confident machines appear. It will be defined by how well humans understand their limits. If you want clear, grounded explanations of artificial intelligence, robotics, and emerging technologies, subscribe to The Intelligent World, because understanding how technology works is no longer optional.